topic is recursion tree method. It is one of the method to analyze the recurrence relation complexity. Now this method is used to guess the solution for recurrences. That is, it generates a good guess which can be verified further by substitution method. Now taking an example, let us suppose given a recurrence relation Tn is equal to 2Tn by 2 plus n. That means the original algorithm, what it is doing, it is dividing the problem into two equal subproblems and it is calling that recursive function two times, and this n represents the cost of dividing the problem into two equal halves, as well as once you got the result after this from these two equal halves, then merging those results. This is just, we can take the example just like that of merge sort, where for sorting purpose we divide the original array into two halves and you apply merge sort in that, and later on you combine the result. The task of splitting that problem into two halves, as well as com combining the results, that task takes n unit of time. This is the cost. N unit means the cost of dividing the problem into two halves and further combining those results. Similarly, when we'll expand this equation of recurrence relation further, you will be getting somewhat for Tn by 2, the result will be 2Tn by 4 plus n by 2. Now in this case, n by 2 you can say it is the cost at the second level of recursion, where that n by 2 is the cost of splitting and combining the results which are being fetched from two recursive calls of each of size n by 4 of the subproblem. That means in the whole method of recursion tree method, what we will doing, we will be just capturing all these costs, these costs of dividing and combining, this n cost, n by 2 cost, and so on. Now let us start how your recursive tree method functions using taking the example of one example. Now, for this to solve this recurrence relation, we start with taking four terms, one moment level of the tree. Then tree will be making a tree, nodes and costs. For this purpose of using recursion tree method, we will be generating a tree from this recurrence relation. Now, how this method starts? The first thing we will be using for Tn. For Tn, the initial level is 0. That is the first level. At zeroth level, what we will be doing, we will be representing Tn in the terms of cost function. This cost function, that means if you are solving this problem of Tn, what cost is required to split that Tn function into two parts and further combining the result of these two parts. That is, n is the cost incurred for this, and further the cost is being divided into cost of further processing Tn by 2 section of this and Tn by 2 section of this. That means Tn can be represented as n plus Tn by 2. This is the cost for splitting the and combining the results at the level of zeroth level, that is at level of Tn. Now the number of nodes in the tree at this level is 1. One node is being there only. And what is the cost at this level? That is the value of the node. That is, cost is here n. Now going to this next level, that is level 1, will further expand this Tn by 2 in the form of its cost value as well as its further divisions, like this. That is, Tn by 2 is represented by n by 2 cost and Tn by 4 further. Similarly, Tn by 2 in this side. Now, how many nodes are there at level of 1? There are 2 nodes. And what is the cost of at this level? This is sum of the cost of this plus this, n by 2 plus n by 2. That sums up to n. Keep on further expanding the similar manner for the level subsequent levels. So like this, in this level we will getting n by 4 and keep on expanding it. The number of nodes here will be 4, and when you keep on adding the cost function at level 2, first plus second plus third and fourth, the answer is again n, because it is 4 times of n by 4 value. Now you are getting at the last, you will be converging the result for t1 is equal to 1. That means when you keep on splitting, the last value n value will become equal to 1. In similar this fashion, you will be getting for the multiple subsection, you will be getting multiple ones for the same at the last level. Now how to get this last level? Let the last level is at the h position. H is the last level. Now what is the specific condition about last level? For last level, n raised to power, because this is n divided by, we can assume it as n divided by 2 raised to power 0, n divided by 2 raised to power 1, n divided by 2 raised to power 2. In general case, you can say here that answer will be n divided by 2 raised to power h. N divided by 2 raised to power h is equal to 1 in this case. That means here the value will be, you will be expanding t1. T1 is nothing but n divided by, the expansion will be n divided by 2 raised to power h here. Then you will keep on representing n by 2, n by 4, n divided by 2 raised to power h in general terms in the form of levels. For level 0, for level 0, the value of node here is n. For level 1, in the one branch, the value is n by 2, and we can say n divided by 2 raised to power level, that is 2 raised to power 1. For level 2, the value at one branch is n divided by 2 raised to power 2, that is 2 ki power level. For the level h, the value will be n divided by 2 raised to power h. Now this final value is 1, that means n divided by 2 raised to power h is equal to 1. When you will be equating this equation, you will getting the value h is equal to log to the base 2 of n, taking log to the base 2 on the both sides. Now you got the value of h, that is log to the base 2 of n. Now similarly, what you will be getting, the number of nodes, these are at level 0, there is a 1 node. At level 1, this is a 2 node. At level 2, there is a 4 nodes. That is, the number of nodes at any level is 2 power level. Now if the level is h, the number of nodes will 2 raised to power h. Here, because the level here is 2 log to the base 2n, the value here will be 2 power log to the base 2n, that is nothing but equal to n. Similarly, fetching the cost values, here the value of cost will be n. Again, when you are doing summation at this level, cost is also n. When you are doing summation at this level, cost is n. Because there are n nodes, that is there are n ones, the cost here is also n. Now adding, that is adding 1 n times, that will lead to n. Now the next thing is, now we have got the last total number of nodes have been written, cost has been written, level has been written. Now how to find total cost? Total cost is summing up the cost of every level. Summing up the cost of every level, that is n multiplied by how many times n is being there, that depends on the number of levels. Here number of levels are log to the base 2n plus 1, because 0 is being added. So the total cost is n times multiplied by log to the base 2n plus 1, that is, it is a big O of n log to the base 2n complexity. Now if I try to conclude this recursive method, basically, this recursive method first converts that original recurrence relation into the form of tree, where each node represents the cost incurred at that level of recursion. Now n by 2 represent that cost incurred at this level of recursion, and so on. Now we sum up the cost within each level of the tree, like we sum up the cost, let us suppose at this level of the tree. And once we got this level by cost, then we find the total cost of all the levels of the recursion, like this, that is n log to the base 2 of n. Now taking one more example, uh, let us first take the example tn is equal to tn by 2 plus 1. Here you should assume that t1 is equal to 1, which is given to you. Now how to start with the same? Just go for the level and try to expand it. Start from the tn node, and the cost here is, because there is just a one split, there are no two factors, just the problem is reduced to half of the original, and the cost for reducing that is 1 unit and tn by 2. At level 1, what you will be doing, that number of nodes are 1, that is 1 is being given, and cost is also 1 unit. Now for Tn by 2, again 1 plus Tn by 4, that is at level 2, and the number of nodes here are also 1 and the cost is also 1. Now moving further, you will be getting this in such manner there will be log to the base 2n levels, because always your problem is being reduced to half of the original till the last level will be log to the base 2n. Because, and if you keep on uh, moving further, then problem will be of size 1 unit, that means n divided by 2 raised to the some ith value, and divided by 2 raised to power I will be equal to 1, that means at the level log to the base 2n, that your tree will not further propagate. Now what is the total cost? Total cost here will be, one is being added, but it is added log to the base 2n plus 1 times. So the output for the same is order of log to the base of 2n.